All right, we start a new chapter, chapter 6, and chapter 6 goes into um, ratios and proportions. 6.1, we're going to talk about ratios and rates. If you look on the screen, a ratio is a way to compare two quantities using division. You can write them three different ways. So you can write them either the ratio from A to B, or A semicolon B, which means, or not semicolons, like brackets, and that's another way of saying A to B as well, or A over B as a fraction. Examples of some ratios like we have written on the board here. One can be the number of correct answers on a test compared to the number of total questions on the test, and that gets your, like a percentage or points. How, when you are dealing with ratios in that aspect. Another aspect would be the number of boys in a class compared to a number of girls. So like say A in this case would be the population of boys in a classroom, and then B would be the number of girls in that same classroom. So we can say like the number is, A to B or whatever, 22 to 16 or something like that. So that's how we kind of identify ratios. One of the things that we're going to talk about, and the things that you're going to be asked to do in your homework, is to compare two ratios by converting them into decimals and then compare the decimals, because equivalent equivalent fractions have the same decimal. So if you bring them into decimal form, and if they have the same decimal point, then we can make the conclusion that they are equivalent ratios. So if I take a look at, say, 3/8, I want to see if it's equivalent to 21 over 36. You can use the long division in order to help you determine whether these are equivalent ratios or not. So here this would be 3. So I'm just doing the long division to help me determine what decimal these two fractions will become. This becomes 4, that's another 0, and that's 5. So, and that's give me 4, and that give me 0. So the decimal for 3/8 is 0.375. If you look at 21 over 56 and do that same thing, I think this will be 3 again, so this is 168. 210 minus 168 gives me 42. Bring down the 0. 56. I think it goes in 7 times, which gives me 392. And that gives me what, 28? And then 56 times. Yep. So these are equivalent fractions because they have the same decimal point. You can do it like that, or you can also look at them in a sense of 5/8 and 625 over 1,000. Another way you can do it is this, is I'm going to take 1,000 divided by 8. And that's going to give me 125, because 8 times 125 is going to equal 1,000. So now what I have to do is if I multiply this by 125, well, I get 625. So 5 times 125, that gives me 625. So yes, both of these are equivalent ratios. Two different ways to solve it, still get the same answer. Okay? The next thing we're going to talk about in this section is rate. And rate is a ratio. It has two quantities measured in two different units. Like miles per hour, feet per second, stuff like that. A unit rate is a rate that has a denominator of 1 when expressed in fraction form. So, if I look at these examples, they're asking to make the following in unit rates. So from the definition tells us that we have to place the denominator with a value of 1. So the only way we can do that is by taking the value on the top and dividing it by the value on the bottom. So 330 divided by 5 will give me 6. And so I can write this as 6 miles per 1 hour. Okay? Second example, do the same thing. Take 40 divided by 20, which then will give me 2 gallons per 1 hour. And then the last one, which is 25 fish over 4 hours, 25 divided by 4 gives me 6.25, so I can write this as 6.25 fish per 1 hour. Now, I write it as a decimal on top because they're asking for unit rate. They want this bottom value to have a denominator of 1. So you have to put in decimals in the numerator for this specific example to be hold true in unit rate. The last thing we're going to talk about is filling in the blanks so that the rates are equivalent. This gets into what is called dimensional analysis. So when we have dimensional analysis, you are given certain values in your numerator and the denominator to begin with, and then they're going to ask you to have some specific measurements in the numerator and denominator to finish with. And here is how we solve it. So we are given centimeters to minutes, and we want to convert meters to hours, and they want to be equivalent. So here's what we're going to do. First step is you're going to rewrite this value. So we're going to put 5 centimeters per 1 minute. Okay? I want to convert that bottom measure into hours. So here's what we have to do. We have to do some canceling out, but we're gonna multiply this by some fractions. So the first thing we're gonna do is I'm gonna write minutes on the top, and I can convert minutes to hours by saying that 1 hour is equivalent to 60 minutes. Now the reason why I can write that is because technically this 60 minutes divided by 1 hour gives me a value of 1. So this is just a way of being able to convert my expressions with different unit rates. What I can do from here is, see how I have minutes on the bottom and minutes on the top? It's kind of like canceling out, like when you have fractions like this where you have 3, like say 3/8, and you multiply by 2 over 6. You see, oh, you can multiply this by 2 to get 1, and multiply this by 2 to get 4, and then you multiply this by 6 or 3 to get 2, and multiply this to get 1. So you're getting 1 right there. That's like writing 1 right here. You're just canceling those out. And now I have hours on the bottom, which is what we're looking for here, so we don't have to do any more conversion there. Now I have to get rid of the centimeters. So I know I'm going to put centimeters on the bottom, And the next conversion here would be meters. And 1 meter is how many centimeters? In this case, it happens to be 100. So I can go cross out, cross out. Now I'm left with meters on the top, which is what they have here, and I have hours on the bottom, which they have here. Once I do that, I can just multiply them across. So that gives me 5 times 60 times 1, which gives me 300 meters per 100 hours. Okay? But they're wanting me to find when the hours is 1. So I need to take 300 and divide it by 100 to get my unit rate. And so this value here is going to be 3. Okay. Next thing we look at is 5 meters per 1 second equals some meter per 1 hour. Well, here I have meters on the top and meters on the top. So I don't have to do any conversion with that. All I have to do is convert it from seconds to hours. So, same thing, 5 meters per 1 second. I'm going to multiply it by an equivalent fraction. I'm going to put seconds on the top because I want to cancel that out over the next consecutive unit would be minutes. Okay, so 1 minute equals how many seconds? That happens to be 60. So now that cancels and that cancels. So now we're at meters per 1 minute. We're not done yet. So now I need minutes on the top because I want to cancel that out and bring it to hours. And again, 1 hour is 60 minutes. Cross it out, cross it out. I got hours on the bottom. I've already had meters on the top. So now I just multiply 5 times 6 times 6, which gives me 18,000 meters per 1 times 1 times 1, 1 hour. So the value in that question mark will be 18,000. Last example. I got 3 pounds over 1 equals question mark ounces over 1. Again, all I have to do now is convert pounds to ounces. So I'm going to rewrite my fraction from the left. I'm going to multiply this. I know I'm going to put pounds on the bottom because I want to cancel that out eventually. And the conversion from pounds to ounces is 1 pound is 16 ounces. If you do not know some of these conversions, like minutes to seconds, days to hours, months to weeks, etc., look them up. Type in pounds to ounces on, some of the search engines, and you should be able to figure out what the conversion is. So from here, this cancels out and this cancels out. And I'm now got ounces, so now I just multiply them across. So this becomes 48 ounces per 1. And so the question mark would be 48. All right? And that is being able to use ratios and rates. Hope this helps. Till next time.